I made a video about a year ago where I promised to make a sound design tutorial if enough of you were interested, and there were a bunch of comments saying that they would love a sound design tutorial, and I have continued to put it off and off and off because it's a really huge topic, and I was trying to figure out a way to make it concise enough to be, consumable in one video. But I decided it might make more sense to just break it up into several different parts. So let's consider this part one of my series on how to do sound design. So today we're going to be covering the absolute basics, like floor level, the literal first things that you need to understand to start to understand sound design. So if you're not a complete beginner, this video might not quite be for you, but if you are, welcome aboard. I do hope this is helpful. Let's dive right into it. So today I'm going to be using arguably the best free wavetable synthesizer that is available on the market right now. It's called Vital. It's totally free to grab. I'll leave a link in the description if you guys want to pick it up yourselves and follow along. And I think it's a super useful tool to learn sound design because it's super visual and it's got basically all of the parameters that you're going to find in other, more premium plugins. Though I should say that I don't know that there's much of a reason to get those more premium plugins unless there's specific, preset packs that you want for, say, Serum or something like that. But yeah, let's kind of dive into what the interface is, what all of it's doing, so that as we get into the future videos, there will be a little bit of a foundation for things to make sense. What we've got here is 3 oscillators. And so an oscillator is essentially the thing that's making noise in the plugin. When you look at an oscillator, it's going to have a shape of a waveform. So this is one unit of a waveform that repeats infinitely over, whatever period of time that you're holding a note down for. So the simplest way to understand is the sine wave. This is a nice smooth curve that oscillates up and down once per unit of time. And now the frequency of those oscillations from the high point to the low point is what determines the note. So if we looked at a parametric EQ, for example, you'll see that with a sine wave, there is just one single peak with no other information coming through when we play a note here. So pick like a middle C. You see there's this nice, clean, narrow, sharp peak. That's basically saying that this is the only harmonic information that's coming out of the VST. And then as you move up the scale, the frequency moves up accordingly to follow the note, because like I said, the frequency of the oscillation is what determines the pitch of the note. And then every time you double the frequency, you go up an octave. So here we're at this lower C, we jump an octave, it's now twice as high in the frequency spectrum. So that's sort of the first fundamental piece of information you'll need to really understand what each oscillator is doing. But something super interesting that we can get into right away is what happens when we have a little bit of a more angular oscillator here. So let's go back into basic shapes. So now when we've got this more angular oscillator, it's still the same thing. It has a peak at 1/4 of the way through at the high end, a peak 1/4 of the way at the low end. And it's relatively smooth compared to what we're going to get into in a few minutes. The most important thing to understand is that these angles are going to add what's called harmonics. So I think the best way to demonstrate that is just visually. So if we take a peek back at our EQ here, as we play these same notes, you'll notice that there's a little bit more harmonic information because of the harmonics that are being added by the angularity of the oscillator. So you see all these high frequencies that get a little bit less intense as you go up the frequency spectrum. That's exactly what is being added by the angles. When you get into the nitty-gritty of the why and the how, it's really just a matter of things are moving essentially more quickly than the computer can create, which creates artifacts. That's a gross oversimplification, but that's exactly what we're here for, is just kind of basic broad concepts. But the important thing to understand is that these harsher angles are going to change the harmonic content of the sound. So when we look at the pure sine wave, a nice single peak, we make it a little bit more aggressive. We add just a few harmonics because of these added angles, even sharper. A bunch of this buzzy white noise. Now this here is an even steeper single angular change where it's going high and jumping immediately to low, which again, the computer can't turn in an instant from the high point to the low point, which creates artifacts. So then we get a ton of high buzz out of this more aggressive saw shape. A square, same thing. We're going full high, no slope up to just a full drop down. So you'll again expect even higher information. And you can see that and hear it, I hope, depending on what you're monitoring on. So that's fundamental idea number one, is exactly what oscillators are doing to the pure tone of a sine wave. As you get a little bit more involved, you can get oscillators that do some pretty wacky stuff. Like this is a brown noise oscillator. I'm expecting this because of all the jaggedness to have a lot of high-end information, maybe not quite as much rich subbiness because that's what's coming from that pure tone. So let's hear it on like a lower C, middle C, tons of buzz, tons of noise. So as you start to get more familiar with the looks of oscillators and what those sound like, it'll be a lot easier to sort of think about what sounds you're going for and how to get there with the right oscillator. Let's get this back to a sine wave and we can talk about the next fundamental concept of any type of de novo synthesis here, and that is the ADSR envelope. So you're gonna find this on a lot of plugins, really most instrument VSTs that are synthesis based. They've got what's called an ADSR envelope. That stands for attack, decay, sustain, and release. And sometimes you'll see a delay knob, which Vital has in this case. Really, they do kind of exactly what you would expect them to. So let's start with the attack because I think it's maybe the simplest, but essentially this is referring to the very start of the note. So in this case, the attack time is down very low, which means the time from absolutely no noise to the loudest noise that it makes is extremely low. In this case, it's 0.0 seconds. Whereas if we turn it up, we can see visually that the amount of time it takes for the volume to reach the highest point is now 0.5 seconds. And so what that sounds like, it swells into it. In Vital and in a lot of other plugins, you can actually drag and shape the attack time so it kind of starts quickly and then slowly reaches the top. Or you can get sort of like a forced sidechain sound where it is very quiet at the beginning and then shoots up. And then the decay time is how long it takes to get to the level you want the sustain to be at. So now we can start talking about really shaping the envelope to give it a certain feel, certain motion. So let's make this the first exercise in the series of trying to think of a sound and then create it here. So we've got our basic shape, pure oscillator, so it's not going to be super buzzy. And let's think about what we want the volume envelope to look like. So let's say we want to make a sound like ping, ping, something like a pluck, right? You'll notice that my lips are stopping the sound from escaping altogether, and then as soon as my mouth opens, the sound reaches full volume and quickly falls away. So if we wanted to do that in our ADSR envelope, for example, we would have an attack time of 0 because lips stop the sound, open my mouth, it reaches full volume. We'll turn the sustain down all the way so that even if we hold the note, it doesn't just keep ringing, and bring the decay in way down so that it can kind of match the speed of the ping noise I was making. And you end up with something like this. So you'll hear in this case, there's a little bit of a click at the beginning. Obviously, I'm not trying to make exactly the noise that I made with my mouth, but if you ever wanted to deal with that click, you'll just turn this attack up ever so slightly, and it'll have a really rapid climb rather than just suddenly cutting into the waveform. So that's pretty close. Now let's say we wanted it to be a little bit harsher, have a little bit more harmonic content. Now all of a sudden the sound's getting a little bit more interesting. Just a little bit of ADSR and a slightly different basic shape. We're getting a little bit closer to the actual voice we were talking about. And then quickly getting into the other components I haven't used in this particular case. We do have a delay, which essentially just shifts the time that the sample actually starts. So you strike the note and then there's a delay of however long you set before the signal actually starts going through the ADSR envelope. I don't tend to use this a ton in my own sound design applications. I find it kind of frustrating when I'm making an instrument I can play and then it doesn't respond immediately to my touch. but that is an option if you ever wanted to use it. And then similarly, we have a hold time. So let's say our decay is slow, or our decay is quick, our sustain is low, but we want, you know, there to be some period where it stays high. So now, no matter how long you hold the note for, it will stay at that volume for as long as you hold it. So let's say we've got like, you can let go right in the middle of the decay, and you know, if your rhythm calls for it, or you can hold for a really long time and let it ring all the way to the sustain. That's essentially what the hold does. And then finally with the release, this is super useful as you're starting to shape sounds, in my experience, where you want them to flow into each other a little bit more, and kind of not necessarily a sloppy way, but make it feel a little bit more kind of dragged out. So what that's going to do is, even after you let go, or when you let go, it'll trigger the release part of the curve here. So you can hear there's that longer tail as the volume falls off. And with any of these, you can change the shape so that, you know, say the release is more of a cliff or more of a subtle tail. And you can make it longer, shorter, very steep. And all the way to 0 is a complete fall off. You'll probably end up with some slight artifacts. Just the popping. And essentially what that is, if you're a really visual person like I am, imagine that the computer is reading the oscillator, you know, kind of linearly through the oscillator. So you've got your sine wave here. I will see if I can edit this on. I'm not very good at editing, so I probably won't be able to. But you got your sine wave rocking and rolling. If you pick up at the peak of the sine wave, the computer needs to get from its baseline all the way to wherever you are on the curve. And the same thing happens when you just suddenly cut off. So that's why you get clicks and pops. It happens in your audio tracks. It'll happen in your synths as well. So that's something to keep an eye out for, is you always want to try to get back to the set point before fully cutting the audio or the signal out of any kind of synthesizer. So yeah, that's the ADSR envelope. Maybe gonna be one of the most important things when it comes to shaping sounds to be just the way you want. But this next tool I think is super cool for really giving sounds a lot of life without a ton of like added effort in the mix. And that's using the low frequency oscillators, which is what LFO stands for. Once again, you're gonna find these all over the place in basically all synths that you bump into. They're super useful for automations in some of the effects that you can do, or even some of the shapes they're using for the oscillators. So in Vital, it's really nice that anything that's got this kind of four-way arrow here is something that you can automate. So if you click and hold and drag it to anything that's lit up green. So in this case, let's say I go to, yeah, we'll see what happens if we go into the basic shape here. So maybe the basic shapes isn't the best example of this. Let's see if we can actually go to a... So now that we've got the LFO routed to something that's more of a wavetable, not going to dive too much into what that is specifically, but essentially what you see is that you move through the wavetable, the oscillator itself changes. This is essentially just the reading frame of, you could imagine like a three-dimensional table with different topography. The computer's only reading a single two-dimensional frame of that. So as you move through the wavetable, the topography changes. That's essentially what we're doing. So now we've got an LFO moving at a half note tempo that is triggered by the note to go up to the top of our automation range, which is, you know, arbitrarily 213. You can turn that down, turn that up. It's indicated by this nice little green indication. So if we want to get all the way through the wavetable, we turn it all the way up, bring this all the way to the bottom, and then we'll have the full range of the wavetable as the note plays. And it'll move up and down every half note. So you can hear how that's a lot more interesting than if we picked just one oscillator position and just let it ring out. It's just completely static, whereas with the LFO tool moving through the wavetable, it has a lot more life to it. It's moving a lot, it's changing the stereo field, the harmonic content's changing. So you can just imagine that as you start kind of adding these LFOs, changing the time that they're moving on, changing the shape that they're moving on, you know, adding extra peaks and doing crazy stuff. You can automate this to the wavetable position, you can automate it to the level of that certain oscillator, the pan, and you can even get into some of the effects where you have reverb coming in and out, some delay, maybe compression, really anything that you can possibly imagine. The world is your oyster. So you may be wondering why exactly there are 3 oscillators on this, if you know an oscillator is the thing that makes noise. And that's essentially because with synthesis, it's really useful to use layers to really shape a sound. So in this case, you just heard the layer we've got here as this solar powered layer. You know that a saw wave is extremely high harmonic biased because of that sharp angle to the oscillator. Now let's see if we can just find something that looks interesting. Drink the juice. I like this just because of the name. With just our solar powered oscillator, sounds familiar. Just a nice buzzy oscillator there. Add the saw wave and you'll notice there's a whole bunch of new harmonic content despite being the same note. So we get all that high end buzz. And then once again, the third oscillator is going to change it even more. So what's happening is that all 3 of these oscillators are feeding into the same output. They're interacting with one another and essentially, you know, phasing and canceling each other out to create a third or a fourth totally new sound wave out of the component parts here. So these 3 randomly selected oscillators aren't the best example of how useful that can be, but it is something to keep in mind that as you're designing sounds, it's going to be really helpful to layer something that's, say, like basic sine wave with something like drink the juice, and you can use the level here to kind of mix them in so that you get just a little bit of flair to what is otherwise your just pure sine wave tone. So the final thing I think I want to get into in this super basic overview of essentially just Vital, but more broadly sound design, is this effects tab in Vital. So you've got a few stock effects to choose from directly in Vital. All of them are really solid for, once again, being a free plugin, highly usable. So a chorus, in its simplest explanation, is essentially taking what is an otherwise completely mono, pure signal like we saw in the EQ with the sine wave, and kind of chopping it up, moving it around in the stereo field with different amounts of delay so that it feels basically bigger. So hopefully you'll be able to hear it right away. This is just with the kind of stock preset here. So you can hear how it's waving back and forth, and actually something I forgot to mention earlier is that Vital has this really nice visualization up here in the top right where you can see without the chorus our sine wave is just a sine wave repeating, you know, periodically at a normal interval, and the amplitude of the sine wave is changing according to our ADSR envelope. So when we start, it peaks, gets really loud, and then settles out and hangs out at our sustain volume. So not a lot of motion once it hits the sustain. But then when we add the chorus, you'll notice that the sine wave starts moving around a whole lot more. So if you can see how it looks like there's 2 waves sort of superimposed that are dancing around one another, that's exactly what I'm talking about with the phasing. It's separating it into multiple sounds and then moving them around a little bit so that it feels like there's more than the one voice playing. The compressor here has a multi-band, low band, single band mode. It's pretty solid, just kind of a basic multi-band compressor. Don't want to get too in the weeds with this really, but essentially all a compressor is doing is setting a threshold and then allowing a certain amount of sound to get through past, you know, above or below the threshold you set. So this is really useful when you're trying to either take some certain characteristics out of a sound or bring some certain characteristics out of a sound to reduce things you don't want or bring more of what you do. I don't think the sine wave is going to be a particularly useful demonstrator, but you know, here I've cranked the highs of the sine wave It's done absolutely nothing because it's just a sine wave. If we move to something with just a little bit more harmonic information than a sine wave, you can hear that there's that high info going on. If we really crank the high info, brings that out, bring it down, mellows it out a bit. So this is just one way to sort of shape the sound, glue it a little bit more, compress it based on frequency bins or as a full single band. So if we just wanted, say our attack is hitting too harshly, this will help limit the loudest it gets. So you can see the difference between what the sound should be and where the sound actually should be. So that's all the compressor's up to. Delay, similar to an echo, just basically adds a repeat of the sound based on whatever time that you want it to be. So if you click and drag in either direction, you can make it faster or slower. You can drag the feedback way up so that the delay will last a lot longer and continue to be loud for longer. And then the mix is how loud you want the delay to be. So if you wanted only delay, you'll notice that the actual note being the first line is big with no delay. As you turn the delay up, the delay sounds get louder, the initial sound goes away. You can pick different stereo options. So if you wanted it mono, just all of the sound to be right at the middle. Ping pong will go between your two ears, visualized nicely here. So you can really hear those bouncing back and forth. And then mid ping pong is basically a ping pong and then there's one up the middle. Once again, visualized nicely. Distortion, this is gonna do a similar thing to adding angularity to your oscillators, where it's just basically adding more harmonic content to a sound. And again, the most basic explanation. So by now you're probably familiar with what the simple sine wave sounds like. Whereas if we've got a little bit of distortion on there, we can add a lot more fuzz there. This might be easier to dial in for certain types of fuzz that you want. This obviously sounds a lot softer than adding, drink the juice. That's got a lot more really high-end buzz. This does something a little bit, actually, yeah, let's visualize that as well. So without our distortion, our friendly single sine wave, and with our distortion, we get a nice array of upper harmonics. There's a few different types you can choose from. Some are more aggressive, you can tell by the angularity. EQ, it's just an EQ. It's basically a 3-band. You can do a low, high, and then a band pass EQ just to scoop some frequencies out. This is useful to shape a sound without having to load another plugin, or say you've got something that you want to be statically affected, or if you want to even use an LFO to apply to any of these effects, that can be really cool to give it some life. Filter does basically a similar thing, do a low or a high pass EQ. Flanger is philosophically similar to a chorus, doing kind of a slightly different thing. It's applying some frequency boosting that's moving around in its phase to add what's called flanger. So once again without, then the flanger starts doing some cool stuff to this waveform here up in the top right. So it's a pretty slow progressing flanger. We can speed that way up. You can really hear it move around now in the stereo field as the phase is changing. You pair that with chorus, you can end up with some pretty cool textures. And end up with some really nice big sounds that take up a lot of space. Might as well throw the phaser in there too. This is essentially, once again, taking the sound and forcing it to interact with itself so that certain bits of it are cut out at certain parts and other bits are amplified. As far as interpreting this visually goes, there's, two curves that are shaped exactly the same in this case. And basically these two curves are additive, right? So in cases where two peaks are together, that frequency is going to be boosted by those peaks combined. In the cases where two valleys are together, that frequency will be ducked by those valleys combined. And then in cases where there's a peak and a valley, so like right here, for example, the net difference, so somewhere right in the middle, will be what that frequency shows. And as this moves back and forth, the phase changes in certain frequencies, which again gives it this kind of more like three-dimensional feel. So let's listen to that by itself and then pair it with these other two kind of time affecting sounds. So by itself, it feels relatively similar to the flanger. Let's get that up to the same speed as the flanger, actually. So you can hear how the volume goes up and down as those frequencies start phasing in and out, basically. But then once again, we combine that with chorus and flanger, we start getting some pretty groovy tunes out of this. Getting some slight distortion from the volume peaking at certain points when the phases are all in line and everything's working together, and then big cutouts. It's bouncing around the stereo field. It's really transforming stuff from what is literally just the most basic sound that you can generate. Then finally, reverb. I don't know that you need me to explain what reverb is. I probably didn't really need to explain what all of these are, but I did anyway. Anyway, I think that's everything I want to go through as far as the absolute basics of the interface of a wavetable synthesizer, Vital in particular. Everything I talked about here is perfectly applicable to most wavetable synths. But yeah, let me know what you think would be helpful in future installments of this sound design series. I want to make sure that these are like, you know, kind of bite-sized and consumable rather than this overwhelming onslaught of information. So let me know if you think it'd be helpful if I kind of like showed you how to make certain sounds, or just kind of continued going through slightly more advanced concepts, building up to eventually making any sound you can possibly imagine, I suppose. Yeah, let me know what you want to see. I'm happy to make any and all of it. And as always, leave a comment, let me know if you have any questions, and think about joining the Discord. Super helpful place. It's a good way to ask me questions directly and tap into some of the other great producers in this community for all of their great knowledge. Thank you guys for stopping by. I do hope it was helpful, and I will see you next week. Peace.